Hello, everyone, and welcome to our webinar, 3D Printing and Injection Molding. Same team, different roles. Featuring our speaker, Brianna Gillette, Account Executive for the Southeast region for Eccentric. Brianna is an account executive supporting clients in the Southwest region with their prototype projects. Prior to Eccentric, Brianna spent 5 years at Stratasys serving multiple roles. You can connect with Brianna using the contact information on the screen. This presentation is expected to last approximately 45 minutes. There will be a Q&A session at the end of the presentation. So please use the questions field on your screen to ask questions during the presentation, and we will address those at the end of the webinar. We encourage you to follow Eccentric Mold and Engineering on LinkedIn so that you can stay up to date on our latest blog topics and webinar schedules. This presentation is being recorded, and we will send a link out to the recording within a few days. I now turn over the webinar to Brianna.
Thank you, Mark. Hi, everyone. Good morning or good afternoon, depending on what part of the country you're in. As Mark said, my name is Brianna Gillette, and I'm the account executive for the Southeast region here at Eccentric. We really appreciate you taking time out of your busy schedules to be here with us today and to learn more about how 3D printing and injection molding, or as we like to call it, prototype tooling, can both fit into the overall product development process and how they can complement each other, and of course, how they can be beneficial to you, especially as we're all adjusting to our new normal in the midst of COVID-19. My contact information was listed on the previous slide. We will be sending a copy of this recording out in the next couple of days. If anybody has questions or needs help with anything after the presentation, please don't hesitate to reach out. I will gladly welcome the opportunity to connect with all of you. And as Mark said, prior to joining the team here at Eccentric, I spent 5 years at Stratasys in their direct manufacturing division, where I was responsible for heading up the inside sales team for the organization. And I've worked with thousands of customers on custom 3D printed and injection molded parts. So I've had the pleasure of experiencing firsthand how the two processes can really lend themselves to one another and how they can improve the overall product development process. So I'm really excited to share this with all of you today. Here's a brief overview of what we're going to cover today. We'll start out just generally speaking a little bit about the overall product development and prototyping processes with regards to manufacturing, especially now during these unprecedented times. We'll take a look at how things have changed from what we're used to, and we'll take a look at some good questions to ask ourselves as we attempt to navigate our new path to production. Next, we'll dive into when to use 3D printing and when to use injection molding, depending on which stage of the product development cycle you're in, and how both of these processes can really complement one another. Then we'll shift gears a bit and talk about how Eccentric plays a role in this process and how we can help you bring your products to market faster while mitigating risk. Next slide, please. Thank you. So COVID-19, the great disruption, as we all know, the coronavirus pandemic has created uncertainty everywhere, but especially in product development timelines, regardless of what industry you're in. Future development plans, future consumption of your products or services is more in doubt now than ever before. And any plans your organization had made for the second half of this year or for next year or even further into the future, it's all out the window. Everyone's talking about the new normal. And even though that really sounds cliche, unfortunately, it's something that we will all need to adapt to. So all of this affects the supply chain, and companies have to be more dynamic than they were even 6 months ago. They have to be constantly reassessing and reevaluating each step of the product development and production process. But still, at some point, fingers crossed, we're most likely going to return to a normal planning cycle where we can look into the future far enough to be able to firmly commit to things like product volumes, development timelines, launch timelines, and getting products to market. So what's the best way for organizations to plan for a return to normalcy, while at the same time being more flexible in situations where the supply chain is at risk? We can start by asking ourselves some hard questions. And even though it may not be comfortable, we need to ask ourselves these questions in order to plan the best course of action moving forward. Next slide. All right, so let's take a look at some of these hard questions and how it can impact you directly. The biggest issue is fulfilling demand, especially during a global pandemic. So let's be honest. COVID put a kink in the global supply chain. It exposed weaknesses with the power to completely stop the flow of business, regardless of industry. So now, as all of us are doing what we need to do in order to adjust and work towards a new business as usual model once the pandemic is finally over, manufacturers are being forced to rethink their supply chain. And because of this, instead of relying on suppliers overseas, companies are looking at opportunities to create a more robust and a more sustainable supply chain here at home, a supply chain with the flexibility to meet changing production needs and the accessibility to do so while being more reliable and at a much faster speed. So now manufacturers have to start this process of establishing a more resilient supply chain that can stand up to the unexpected and continue to thrive during these uncertain times. In order to build a supply chain like this, a manufacturer's plan really should include three essential things. Number one, they need to improve supply chain visibility. Number two, partner with suppliers that can quickly scale, especially when mass production is needed quickly. And three, prepare a detailed action plan for transforming to a more digital ecosystem, especially now while everybody is working virtually. So for example, let's say you're an engineer working for a medical device company producing various parts, both hardware and consumables. The company originally had contracts to supply equipment to thousands of hospitals across North America. However, most, if not all of these thousands of hospitals' budgets are completely messed up because of the pandemic. So now the device company has no idea what product volume will be needed going forward. And another obstacle that companies in any industry may face is the need for testing. Specifically, engineers may not be available to run a test that the company is expecting, or if they are available, they may not be able to evaluate the outcomes of the test by a certain time. The company's in-house testing may have also been suspended or repurposed in a different direction, which can completely throw off production timelines. Thanks a lot, COVID. So even though, again, it may be really uncomfortable or even scary to think about these things, we really need to ask ourselves, what are the impacts to my supply chain? What product volume should I commit to, especially with the supply base or manufacturing base? And most of all, what's the bottom line? All right, next slide, please. Okay, so we have a quick polling question for all of you, and we'd like for you to select one of the following answers. How has your business been impacted by the coronavirus pandemic? Demand has been unpredictable, demand has risen, demand has dropped, or no impact at all. So if you could please select one of the following answers, we'll give you a couple of minutes here to do that.
Right, well, Brianna, it looks like almost everybody has voted, so I'm going to close the poll now
All right,
and
thank
share
you.
the results.
Okay, let's take a look. Wow, okay, so it looks like 30% of us have seen an unpredictable demand, as I figured would probably be the case. 22% have seen an increasing demand. 30% have reported that demand has dropped. And I guess the lucky 17% of people are saying that there's no impact at all. So as you can see, the answers are kind of evenly spread out, and it really depends on the individual company or industry, but it's really important to understand how the product development and prototyping process can work regardless of where you're currently at, because things can change at the drop of a hat. Next slide, please. Thank you. Okay, so now I'd like to dive a little bit deeper into the product development and prototyping process. I know I've alluded to it a little bit before. So each phase of this process has been proven out and used time and time again to develop new products like clockwork. The process starts with having an idea. It can be something as simple as a sketch on a napkin or a piece of paper. And then taking that sketch and creating a CAD file in SolidWorks or a similar program. Then once you have that ready, you would move into actual physical prototyping, like 3D printing. This is where you would test your design, prove out your concept, make sure everything's good to go, and then you would move to pre-production or short-run production to verify the design at scale, and then finally you would go to full-on production and getting your products to market. So we found that this process is really like a continuum. Each phase is going to build upon the last one. So each time you move to a new stage, you need to take additional steps and you need to build on the previous stage in the correct order to be able to achieve the highest quality products and to bring your products to market as seamlessly as possible. So we've also found that as these steps build on top of one another, if you run into a situation where there's a problem, for example, in the pre-production stage, if you notice a problem, you're going to have to backtrack a couple of steps in the process, possibly going all the way back to the virtual prototyping stage where you would need to change the CAD file instead of just going back one step to the physical prototyping or 3D printing stage. And also, because all of these phases do build on top of one another, if you make a mistake, it won't necessarily be as easy to fix. So this is why physical prototyping and then prototype tooling, which is what Eccentric offers, are so crucial and why they complement each other so well in order to reduce the risk of having to go backwards throughout the whole process and start over and waste a ton of time and a ton of money. Next slide, please. Okay, we've got another poll for you guys. If you wouldn't mind, please answering this question as well. We want to hear from you. Have you discovered problems after reaching production that required changes to be made? Yes, it's happened at least once, or no, it's never happened.
All right, it looks like everybody has voted, so I'm going to close the poll and we'll share the
Excellent.
results.
Okay. Wow. All right. Well, it looks like for 92% of us, yes, it has happened at least once. And for the lucky 8% of us who it's never happened to before, I hope it stays that way. Next slide, please. Okay, so now let's take a look at when it's best or makes the most sense to use 3D printing as an overall part of the product development process. 3D printing is ideal for many things, most likely proof of concept, parts that have very quick turnaround times, anywhere from a couple of hours to a week or two, low volume production runs. I like to say a good rule of thumb is 100 parts or fewer. Designs that have a lot of changes that need to be reevaluated and tested out again and again. Relatively small parts or components, 3D printing is excellent for. Testing and verifying material specs, and then also fit checks and assembly verification. So 3D printing is an excellent way to complement the injection molding or traditional manufacturing process. And in many situations, it's the best way or the only option to hit really tight timelines or to enable end users to quickly prove out their concept before they move forward to production. And this is especially the case in projects where high flexibility and relatively lower material characteristics are required. So companies, as we've seen here, have unfortunately made some mistakes in product design based on an incomplete understanding of technology's strengths and limitations and how they complement one another. And one of the biggest mistakes is not acknowledging that end use criteria can be drastically different from criteria for a form, fit, and function type of prototype. The major difference between prototyping and end use product manufacturing mostly has to do with things such as material properties, accuracy, and the surface finish of what's going to be produced. So for example, when you add the requirement of initial function for testing purposes, it reduces the number of processes and materials available within the additive manufacturing process. And then when you expand an end user's product capabilities to fit a specific application, it even further reduces the number of processes and materials available to keep additive manufacturing viable. And then the final hurdle is production rate, which naturally is going to be related to the unit cost of the outcome, which we'll talk about a little bit more in the presentation. So we've learned in our many years of working with companies across various industries that, like many manufacturing processes, 3D printing as it is today doesn't always have the capability to hit all of the vital criteria that we just talked about: material, cost, property, and speed at the same time. However, every time additive manufacturing makes a step forward, especially in regards to material characteristics and productivity, the potential goes up dramatically. Let's go to the next slide, please. All right, everyone, we have another fun polling question for you. We'd love to hear your thoughts. Has your company ever attempted to eliminate injection molding prototyping by only using 3D printing? Yes, only for a few projects, or no? Please go ahead and select an answer.
All right, Brianna, it looks like everybody has voted, so I'm going to go ahead and close the polls now.
All right. Okay, so it looks like the results are 35% of us have done this before, 12% have done it, but only for a few projects, and 54% have never attempted to eliminate injection molding prototyping by only using 3D printing. All right, thank you for your response. Let's go to the next slide, please. Thank you. Okay, so we've talked about how things have traditionally been done and what the product development cycle normally looks like. And we've talked about where 3D printing can be an ideal part of the overall process. So this is where we can really make a big impact. Once you've utilized 3D printing to prove out your concept and validate your design, this is where injection molding can come into play to complement the process and really mitigate risk, especially now as we're navigating towards our new normal. And tons of us have experienced problems, of course, with the traditional path straight to production, not validating or vetting out the concept with prototype tooling. And over the course of our nearly 25 years of experience working with customers across many different industries, we've been listening to our clients, and we've learned that there's really an alternative way to approach the product development process. And this alternative way is going to save you a ton of time, a ton of money, and a time of headache. And that's what you're seeing up here at the top of this slide. And then the bottom part of the slide, again, is a more detailed version of what we were talking about earlier in terms of your typical product development process. But the top shows how it's been retooled, pun intended, based on a lot of feedback from our customers over the years. And we've learned this is how the whole process really should look in order to get to market faster and have the results that they're wanting. So you can see the differences here. You're getting to production earlier, which is a top priority for the vast majority of our customers out there, because you're not having to deal with the potentially astronomical, crazy time and financial costs that are going to inevitably come along with making production mold changes, tens of thousands of dollars and potentially weeks or months of time to make these corrections. Instead, what we're doing is adding a very small period of time towards the beginning, just in case you need a little bit of a buffer to make any of those necessary design changes, which again, you might not even need, but you would be moving into product pre-validation 6 weeks sooner than if you would be taking the traditional path towards product development and how it's currently done. So not only are you getting to market faster, but you also have that extra little bit of reassurance that everything with your project is good to go. You can report back to your boss, your clients, your teammates, any stakeholders who are involved with the project and say, hey, everything's been proved out. We're going to get to market faster. There's not going to be any costly mistakes to worry about moving forward. We can all breathe a sigh of relief now. And this is a huge bonus anytime, but even more so now during a global pandemic. Next slide, please. Thank you. Okay, so on this slide, you can see a graphic here that really helps drive this home. So if you're in the idea phase of product development, for example, where all you've done is write down a quick sketch on a piece of paper or a napkin, and you say, oh, I want to change that design. Not a huge deal. All you would do is crumple up the piece of paper, throw it away in the trash, and start over. It wouldn't take any time at all, and it definitely wouldn't cost you anything. So then if you go to the visual prototyping stage or the design stage, where you've created a CAD file, you've developed a more concrete idea of what you want to do, everything's a little bit more set, and then you realize you need to make a change, it's going to be a bit more time consuming, might cost a little bit of money, maybe 10 minutes of your time and about $10 to fix. Not a huge deal. And then if you move ahead to rapid prototyping or 3D printing, a change at this stage would typically cost around $100, maybe an hour or two of your time. You might need to go back and make a few little tweaks to CAD, create a new prototype. Again, not a huge deal, but a bit more time consuming and a bit more costly than the previous stages. So the same thing goes for prototype tooling, which is really Accentric's sweet spot and what we typically would specialize in. So if you need to make a change during this stage of the product development process, on average, you'd be looking at about $1,000, maybe 1,000 minutes, so about a week or so of your time. You would need that to make these changes, and then you'll be right back on track. But however, as you can see here on the very last line, there's quite a large jump that happens after that. So when you move from prototype tooling to production tooling, especially in that first product development cycle that we were talking about earlier, some people would jump straight from rapid prototyping, skip over prototype tooling, and go straight to production tooling. What you can see here is why that is not a good idea, right? Because with just this move from prototype to production tooling, you're looking at least 10 times the cost and 10 times the time. It suddenly becomes a huge problem if you need to course correct at the production tooling stage. And unfortunately, we've seen this here at Accentric many, many times. People spend typically a minimum of $10,000 for a tooling change, depending on the project. And in addition to the cost, you're going to unfortunately be looking at a really long period of time to get any changes successfully made and get your parts back on track as well. What this means is if you're skipping the step of prototype tooling, you could very easily find yourself going from a place where it's not that big of a deal to course correct if you find a problem, to a place where you might need to invest much more time, money, and effort into fixing an issue that could have been avoided easily if you had not skipped this step. So I wanted to break this down and provide you with some real numbers and real data to illustrate what the impact to a project's bottom line could look like if this very important part of the product development process is missed. It could really have a huge impact on people's timelines. And in the case of medical devices, it could have a huge impact on saving patients' lives. So with that in mind, let's look a little more closely at the role of injection molding in the product development process. Next slide, please. Thank you. Because it's so easy to use, reliable, affordable, a lot of organizations have opted to invest in 3D printing technologies for the earlier stage prototype parts, like early examples of form, fit, and function. But the further you move through the development cycle towards production, the more complicated projects become and the more difficult it's going to be to achieve your desired outcomes. So like we were discussing earlier, changes may need to be made and things can get really complicated. And this is why companies like Accentric are often called upon to fill that role. And for this and several other reasons, Some may think that they can just skip the prototyping part of the product development cycle altogether. And in cases where you're just making the exact same part that you've made hundreds of times before, you'd probably be fine. But the vast majority of products are going to have at least some minor changes in design or in functionality. And this is where you're going to want to look at utilizing injection molding as a next step. So for example, the way a polymer fills a steel tool, the physical act of it happening may not go the way that it was simulated, following exactly the same process interpreted by an ideal situation in a lab. So if this were to happen and variations are outside the range of acceptable parameters, you won't be able to necessarily tune the process up to achieve your desired outcome. You might end up with a part that warped or has disgusting blemishes on it or just doesn't look good. And these are the kinds of easy fixes that can be caught in that little buffer period we were talking about earlier, production tooling. So injection molding, as we all know, is a traditional manufacturing technique. And with this process, you produce parts by injecting material into a mold cavity in order to create your part. So this manufacturing technique is best used for projects at scale, for higher volume production runs, anything more than a few hundred parts. Final part design, of course, after prototyping, parts of any size or complexity, objects that are going to mate together or move against one another, or parts with very specific material needs. All right, let's go to the next slide, please. All right, it's that time again, everybody. We want to hear from you. Have you experienced a project where you've used both 3D printing and injection molding to launch a product into production? Yes or no? If you could please select one of those answers.
All right, it looks like just about everybody has voted. I'm
Okay.
going to go ahead and close the polling and share our results.
All right, it looks like it's pretty evenly split here. 54% of us said yes, they have experienced a project where you've used both 3D printing and injection molding to launch a product into production. And then the other 46% have said no. So next, I'd like to show you a real life example of this, how these two processes worked really seamlessly together to help one of our clients' supply chains supporting an increasing level of demand for PPE during the coronavirus pandemic. So this is something that we're really proud of. We partnered with Zverse to manufacture face shields. And when we first met with them and they came to us and told us about this project, we learned very quickly that the project was going to need to scale and it was going to need to scale fast. So the project started off with 3D printed shields just to meet the immediate need. But as we progressed, overwhelming demand really required injection molding to produce the shields on a massive scale, and also at a price that healthcare providers were able to afford. So Zverse came to us knowing that we specialize in fast delivery injection molding services, and then they asked us to scale production up to 250,000 units per month. So after proving out the initial concept and meeting their immediate need with 3D printing, we needed to ramp up very quickly. And being able to ramp up quickly to the production of high quality plastic parts in large quantities, and of course at affordable prices, that's really the power of Eccentric's rapid injection molding concept. And because we were able to produce such a high volume of parts in only a couple of weeks, we were able to not only get a client's product to market faster, but in this case, we were able to help save lives. And that's a really powerful testimony of how these two processes can really lend themselves to one another in order to meet the needs of any project, but especially a critical one such as this. Next slide, please. Okay, so what we have here on this slide is an apples to apples comparison of geometry and processes. So this shows what the price point is for the same part in different processes. And you can see here that as the number of parts goes up, particularly for parts that have really complex geometries, the price per piece tends to increase with 3D printing and decrease with injection molding. And while you might have a greater upfront cost with injection molding in terms of the tooling itself, knowing that you're going to need a larger volume of parts in the future, that will help to offset some of that cost in the long run. And this is a really simple mathematical break-even analysis. Not only how many units are you going to need right now, but how many you're going to need in the future. And this is something that I like to share with all of our clients because, let's be honest, many people look at the initial cost of an injection molding quote and they say, oh my gosh, why is this so expensive? And they get major sticker shock. But it's really important to consider the long-term financial applications, and that's really what it comes down to here. And this slide helps to illustrate that point. Next slide, please. Okay, now I want to talk about how 3D printing and injection molding can complement each other and really give you that 1-2 punch to help take your projects to the next level. Using these two processes together is going to help get your products to market faster. And in the case of many companies, especially during a pandemic, it can literally be the difference between life and death, as we saw with our Zverse case study earlier. So to meet product launch objectives and to make sure that everything is on target and everything is going well, an ideal approach is to use an initial low-cost 3D printing process, then evaluate everything and progress to pre-production and rapid injection molding tools, which is where we would come in. So learn everything you can in the early stages about your processes and about your products so that overall you can reduce your risk for the full production tool. And again, the Zverse case study we spoke about earlier is a really good, really timely example of this. It just shows how 3D printing and injection molding are being used right now to produce PPE and other things too, like testing swabs, ventilator components, and a lot of other things that are serving the pandemic response. And not just in the medical industry, regardless of the industry that you're in, utilizing these two processes together at the right parts of the product development cycle is really going to be so crucial moving forward, regardless of the stage that you're in. Next slide, please. All right, we have another fun polling question for everybody. So when you transition in your product development cycle to injection molding, how quickly do you typically need your parts? 1 week or sooner, 1 to 2 weeks, 2 to 4 weeks, 4 to 8 weeks, or over 8 weeks? We'd love to hear your thoughts on this.
All right, it looks like everybody has completed voting, so I'm going to close the poll. Let's take a look at the results.
Okay, so it looks like nobody needs parts in 1 week or sooner. 5% like to have parts in 1 to 2 weeks, 18% 2 to 4 weeks. The majority of people, it seems, require parts in 4 to 8 weeks or over 8 weeks. So the good news is, regardless of how soon you need parts, Accentric has an option for you, and we are here to help. So let's shift gears a little bit here. And even though we focused on 3D printing and injection molding today mostly, we are proud to offer a wide variety of services to support our clients. And one thing I want to call out here is if you have a process in mind that you're not seeing here on this slide, just because it's not listed here doesn't mean we can't help you or doesn't mean we can't offer it. So we do coordinate processes and secondary operations for our clients a lot with other partners of ours. So if there's a process you're interested in, but you don't see it listed here, please don't hesitate to reach out. I would be happy to help. And most likely we already have a partner that offers the service that you're looking for. So when it comes down to it, additive manufacturing and injection molding really offer unmatched capability in terms of materials, fast prototyping and production, cost effectiveness, and the production of challenging part geometries. So rather than choosing one or the other, it's really important to understand how each of these techniques can be used optimally at different points of the product development process. And I hope this presentation has been helpful in clarifying this. Next slide, please. So with that being said, let's talk about some key takeaways from our presentation today. 3D printing and injection molding are both excellent ways to bring your products to market faster. Using these two processes together can help enable and scale the product development process even faster and make it a lot easier. And Accentric is here to help. We are a premier provider of both rapid manufacturing and consultative services. We are here to help you with any project needs that you may have, regardless of where you're at in the design cycle. And the earlier that we can get involved with your product development process, the better. So please don't hesitate to contact me or any of my colleagues. We are always happy to help with anything that you may need. And again, I want to thank all of you for joining us today. And at this time, we'd like to open it up to questions.
Thanks, Brianna. So we'll get started with the Q&A. Again, if you have any questions, you can enter them into the questions section of your screen, and we'll get started. So the first question is, can you share how many respondents were in the polls? And there were 38 people answering most of the questions. So it's a decent size and provides a little bit more meaning to the answers. The next question is, are there differences in tolerances for 3D printing and injection molding?
That's a very good question. So it's going to depend on the process, of course. Typically with injection molding, our standard tolerances are plus and minus 0.005 of an inch. That's going to be a lot tighter than it would be with traditional additive manufacturing processes.
The next question is, in the volume and complexity dictate usage slide, I'll go back to that here. Is the pricing data representative of Accentric's prices or industry averages? And these are actually for comparative purposes only. We took the parts and had them quoted out from a number of different vendors and sort of averaged all the pricing. So that's what you're seeing on the slide here. The next question, Brianna, is at one point I know companies were exploring using 3D printing to make limited molds. Is this still a valid option for companies looking for 0 to 50 finished parts, or have companies moved away from this option?
That's a really good question. So here at Accentric, we do not have a minimum order quantity, and we can make injection molds for parts that only require a few. In fact, I just had a client the other day place an order for 5 parts. So that is definitely still an option. Of course, everything is going to be dependent on the geometry of your part, how soon you need your parts, and various other factors. But if there's a specific project that you have in mind, I would encourage you to reach out and we'd be happy to talk about it with you.
I think the next question is similar. Can you comment on 3D printing being used for the production of the molds?
Oh, okay, I understand. Yeah, in some cases, 3D printing is used to produce the actual molds themselves. Here at Accentric, we make our molds out of aluminum, so it's typically not a 3D printing process. However, there are other companies I know that still do use 3D printing to make molds or master patterns.
All right, next question. What kind of finish options are available for both 3D printing and injection molding? Oops, sorry, did we do that one already? No, I don't think so.
No, not yet. I can speak to that. So with injection molding in particular, we have a variety of finish options from just removing the tooling marks and providing a basic cleaning to making parts completely optically clear to adding a bead blast or texture. And for 3D printing, oftentimes there are a variety of cosmetic finishes such as painting and making the parts shiny and even chrome plating. Another thing here at Eccentric that I would like to mention is we can color match any Pantone. So if you need parts, for example, that are lime green, we can definitely do that for you. We would just need to have the color Pantone or hex code.
Last question I see here is how can I get a quote for 3D printing with Eccentric? Is it the same process as getting an injection molding quote?
Yes, it is the same process, whether you're looking for 3D printing, injection molding, CNC, cast urethanes, anything really. You can go ahead and email CAD files to me directly. My email address is listed here on the slide. You can also visit our website. We have a wonderful quoting portal system right there, which is linked on the presentation as well. So either way, we can help you get a quote. And in addition to myself, we have an engineering partner on our team who will be available to answer any technical questions that you may have. And we're here to help guide you through the entire process.
Going back to the line of questions about using additive manufacturing for production of molds versus CNC machining aluminum. The question is, what is Eccentric's perspective on the use of aluminum versus additive manufacturing for the production of molds?
So I will be honest, I feel that Eccentric has only used aluminum, and I don't know if I would be able to speak to that from a company perspective. But in general, what I can say is the aluminum tools tend to last longer, regardless of the process of how the tools are manufactured. Here at Eccentric, we do guarantee them for life. So what that means is as long as you're ordering parts on a regular basis, at least once a year, we will take care of any maintenance, any issues that may come up with the tool. If it needs any work done to it or anything like that, we would take care of it free of charge for you.
Okay. The next question, following up on the question about our perspective, what are the costs plus or minus passed to customers, if any?
That's a very good question, and I wish I could give you an exact number, but unfortunately, that's something that our engineering team in particular would know the answer to. If you would like to reach out to me privately, I would be more than happy to get that information for you.
Another question, is there a best solid modeling software for creating 3D parts?
So most of our clients and our engineering team here uses SolidWorks. We would really recommend using that one.
Okay. The next question, repeat Brianna's phone number, and you can go ahead and repeat it, Brianna, and I will go back up to the beginning where we listed it so that it's on the screen for everyone to get.
Sure, no problem. It is 586-598-4636, extension 174.
All right, and it looks like maybe one last question here. Do you provide sterile products?
So we are able to provide sterile products. However, we cannot manufacture parts that are going to be implanted into someone's body. But if you need clean room facilities or things of that nature, then we can coordinate that for you.
All right, Brianna, that looks like the last question. So I want to thank everyone for joining us today. As we said at the beginning, we will have a link to a recording of this presentation sent out within a couple of days. If you have any questions, again, you can reach Brianna at the address shown on the screen. And again, reminder, please be sure to follow us on LinkedIn so that you know when we have additional upcoming webinars. Thanks, everyone. Have a great day.
Thank you all for joining.